Hello students, this is Herb Chase from the Department of Biomedical Informatics. Many of you are working on scholarly projects which require patient data from the NYP data warehouse. We have a ton of data and over 20 years from all our patients, all of which is available to you. This podcast is designed to give you an insight into how patient data is stored and the process you must go through to obtain the data. There are several learning objectives to this podcast. First, you should be able to describe the different types of patient data. Understanding how data is stored will make it easier for you to compose a successful data request. Second, you will be able to formulate an explicit request for data so that the data extractors at NYP know precisely what data you want. Third, you should become familiar with the track committee, which I will describe in this podcast, that will be putting together your request and extracting the data you want. Fourth, you should be able to create an actionable request where the track committee knows exactly what data you want and doesn't return a request to be rewritten. Last, you will understand the time course for getting the data you need for your project. You must submit a request well in advance of your scholarly project months to ensure that you have the data you need when you start working on your project. Okay, let's get started. Let's deconstruct a possible project to see what data elements you would need. Imagine that you are conducting a retrospective clinical study focused on hospital readmission of patients with CHF. You propose the following hypotheses. Patients who are readmitted within 30 days are more likely to have comorbid conditions than those who are not readmitted, more likely to be short of breath. In order to pursue this hypothesis, there are several categories of data that you will need. First and foremost, you will need to identify patients with congestive heart failure. Second, you will need to find those patients who were readmitted for CHF within 30 days. Third, you'll want to know all the comorbidities of each patient. Lastly, you'll want some way to identify whether or not the patient had shortness of breath. How will the data extractors go about obtaining this information for you? To answer this question, you will need to understand how data is stored. From the previous slide, we noted that we wanted to find patients with CHF, need to know if they were readmitted, find out what all their comorbidities were, and determine if they were short of breath. The most computable data, easily found by an algorithm or search engine, is structured data. It is a piece of information in an Excel spreadsheet. Examples of patient structured data are lab values, patient demographics, which are stored as codes, and NYP facilities locations, which are also stored as codes. Extracting this data is straightforward and easily accomplished by an experienced IT person. Quite the opposite is true of unstructured data. The free text in the note are words and are not computable unless the data has been converted to structured data. Parsers with natural language processing capability can identify a concept such as shortness of breath and map it to a terminology. Once converted, the algorithm can easily find the code. Some of the data found in the notes that you might want are providers' and nurses' notes, ECG reports, and radiology reports. Note that the extraction of the notes and the processing via an NLP engine take time. There are many NLP converting engines that more or less do the same thing. You see here that the essential elements of the patient's CHF history present within the note can be identified by the parser and mapped to SNOMED codes. Here at Columbia, we have our tried and true NLP parser and mapper algorithm called Medley, which was created by Dr. Carol Friedman. She is one of the giants in the field of biomedical informatics. She has compiled a huge database of terms extracted from NYP patients. I know that she would be delighted to discuss your project with you if you needed terms from notes. One final point about data. There is data that can be directly extracted. Consider lab values. The algorithm finds the specific value after a single query. But there is also derived data from several queries. Consider the goals of the CHF project. How can we find those patients who are readmitted within 30 days? To identify those patients, we would need to first find patients admitted to NYP with CHF, identify the discharge date, and then search for the next admission date for CHF. Establishing this specific cohort thus requires several queries and a calculation. The same goes for the presence or absence of signs and symptoms during an interval between hospitalizations. Let's return to our CHF project. We see that for this project, both structured and unstructured data will be required. Identification of patients with CHF can be accomplished using ICD-10 codes. To determine which of the patients were readmitted, date stamps for admission and discharge can be used. To identify those patients who have shortness of breath, the notes entered to the EHR will be pulled. Then an NLP engine will parse the notes and map the signs and symptoms to a terminology such as SNOMED. Now you are ready to submit a data request from NYP so that they can pull the patient data that you need for your project. These are the 4 key data elements that you will need to conduct your study and the data required to answer these questions. We now know how to answer who has CHF, and we can also figure out who was readmitted by using admission and discharge timestamps. And we can also find the comorbidities by using ICD-9 codes. And lastly, we can figure out who had shortness of breath by looking at the notes and mapping them to SNOMED codes. How do you go about composing a data request and then submitting to NYP? Well, there is the track committee that reviews all requests for data. They prioritize requests and assign the requests to various staff members. What you do is fill out a data request form and submit it to the track committee. In order to access this form online, you need proper NYP Active Directory access. That is, you must have access to the hospital clinical applications, such as the EHR or the CUMC Infonet. If you don't, then your advisor must submit the form for you. Let's look at a data request form that can be accessed online. You'll need to stipulate the time window of the date to be extracted. You must also refine the cohort. And lastly, you need to describe in painstaking detail, and I mean painstaking detail, the exact data elements that you want extracted. The more explicitly you fill out this form, the sooner you will get your data. Here's an example of a well-written data request form. Note how explicit the request is. The SMART acronym, invented by the track committee, reminds the requester of the key attributes of a well-written request. First and foremost, the data request is specific: patients with CHF and not patients with heart disease, for example. Second, the data of interest must be measurable. There are various attributes of a patient's record that you would like. Are they attainable? For example, you might want to know if the patient with CHF had a family history of CHF. There may be no way to get this information because it is recorded in natural language in the note in a manner such that the NLP algorithm cannot correctly extract and map the data. Third, the request should be realistic. For example, you really don't want all the patient data of patients with CHF over the last 30 years. Not only would that request generate an enormous amount of data, which would be very difficult to process, but would also contain patients that were treated very differently from decade to decade. Lastly, the request should be timely. If the track committee requests modification, do so as promptly as possible. Besides the clinical data that most of you are aware of, there are other types of data that might be of interest to you. Some of you, for example, might be interested in quality improvement as one of your projects. Check out the track website to see what other data is available. Data request form. The key first step in considering and formulating a data request is to explicitly define the cohorts. In our case, the CHF project, the cohorts can be explicitly defined. You will want patients with CHF who were admitted, discharged, and readmitted within 30 days. This cohort can be easily identified using these simple attributes: the ICD-10 codes, admission, and discharge dates. As mentioned, you must narrow the time window of the study. You also want a control cohort and can assemble one with slight modification of the query for the main cohort. Once you have the cohorts explicitly defined, You can ask for the other data you want in order to perform the study. In this case, you will want all the comorbid conditions, ICD-10 codes, and the notes of the two cohorts so that attribute shortness of breath can be identified. When defining your cohort using codes, such as ICD-10 codes, you should consider the level of granularity. For example, in your request for patients with CHF, be mindful that there are many types of CHF, each with slightly different codes. You may decide that you only want to study readmission rates in patients with diastolic CHF. There is a code for that, which differs from patients with systolic CHF. Or you might want all patients with CHF, regardless of the physiology. Narrowing down the cohort will obviously decrease, perhaps substantially, the number of patients that will be in your cohort, thus reducing the power of the study. The point here is that the track team can pull patients with as little or as much granularity as you wish. My last comments focus on the timeline. Many of you, of course, are very busy with your clinical responsibilities and don't start thinking about the data you will need until you are nearing your scholarly project months. Unfortunately, there is a time lag, sometimes significant, between when you submit your request and when you receive the dataset. I recommend the following, based on my experiences with students and faculty requesting data. 4 months before the start of your scholarly project time, finalize your project goals and submit and have approved your IRB protocol for the project. The IRB can and often does expedite requests for patient data from the clinical data warehouse. Once you have IRB approval, you can submit your data requests from track. As we have discussed, you will need to identify explicitly the data you are requesting, thinking about how the data is stored, if you will even be able to get that data, and formulate and finalize the query on the data request form with your preceptor. You should expect that it might take up to 3 months to get the data via track. Although the track team works tirelessly to fulfill the request, the number of requests has skyrocketed as faculty and students become aware of the power of data mining. 3 months lead time gives you some time to revise the track request if it is returned to you for modification and clarification. Last point focuses on the data sources available. We have discussed the clinical data that is available at NYP, which is suitable for most of your studies. We do have another set of data here that is part of the worldwide Odyssey project. You should check out their website to see what the mission is and what data is available. The advantages of using Odyssey data is that there is an absolute ton of data, literally hundreds of thousands of patients locally and millions worldwide. The data available, which is completely de-identified, are demographics, the diseases, the medications. If you are interested in exploring the Odyssey database, contact me and I can show you how to access the warehouse. There are other databases you might be interested in exploring, which I will describe in another podcast, Data Mining and Machine Learning. Please don't hesitate to reach out to me when you're putting together your proposal and the data request. I've helped many students and faculty refine their data requests so that Track can deliver the data promptly. In fact, the data extraction team is down the hall from me, and they are happy to sit with us and have them help you design a successful data request. Enjoy your scholarly project time and get the most out of it. Thank you.